Hello everyone, this is Matt at Fisher Custom AV. Coming at you, we're at a church here where we put a new audio system in with new speakers, amps, DSP, everything, to help correct, you can possibly even hear it in my talking, help correct some of the audio, the muffledness, give more clarity, and without putting sound absorption on the walls, do what we can for the echo. The echo is meaty, in the middle range in this church, I'll say it that way. The previous speaker was one speaker, as you can see up in the ceiling here. A Bose hanging, hopefully you can see that well enough, trying to focus, but hanging up in the ceiling, bringing everything down from the ceiling into the church. All right, sorry about that. We had, there's kids coming in here and doing some classes and some things in the back of church, so bear with me if you hear that. But that was their old speaker, a Bose one single point speaker, front of church, high in the ceiling, bringing sound down. Those systems were around a lot in the 90s, even 2000s. Companies and things would install them, especially in churches that have all hard surfaces. The floor is all hard. There's no padding on the pews, brick walls. Everything is hard in here. That is not good for sound absorption. People absorb sound, made mostly use of water, but we're going to absorb sound, but anything hard is not going to. For example, you can hear some of that, but that is going to basically allow sound to just roll through the ceiling. More reverberation, more echo with your speakers up high. So we don't like high speakers in churches because you're going to, even if you had carpet, soft surfaces, the speaker is not where the people are. Pardon my camera work, I'm looking at where I'm going to go next with the camera. But what we did is we put LRC line radiating columns in. These are EV, Electro Voice speakers. 4 total speakers. You have to think of it also, here's our front left speaker. You have to think of it also in the aspect of every speaker you put is a sound inflection. It's another area of sound entering the church or environment, whatever, the building, wherever it is, business, restaurant, whatever. So the reason for having one speaker, I get it. It makes sense in this part of it is that, okay, I only have one speaker. So one point of inflection. The problem is the height. Not a good spot. Hello? Check 1, 2. That's me just talking. You can probably, depending on how the audio is picking up, possibly hear that. So again, the problem is the height of that one speaker. That's just going to roll that echo and reverb everywhere for what the church is. Second speaker we have for our rears is just a little smaller version of an LRC from Electro Voice. So there's 2 speakers on the left, and I'm going to pan over to the right. 2 speakers on the right here. There's the one there and the one up there, and I'll walk over and show them a little more closer to you. We do use engineers. We model these with engineers for the space, height, size of it, everything, width, length, all of that. What are the surfaces? Those go into a computer audio simulator with these particular speakers and say, okay, here's what the sound is going to do. These speakers, they have a narrow and a wide range on them. There's the front right. We have them, of course, in narrow. The narrow range is for your vertical, height-wise, how high, the vertical dispersion of the audio, it's 20 degrees. So 10 degrees up, 10 degrees down off of center. We have them also angled at 5 degrees down based on the simulation for the audio. So 5 degrees down, that means 10 degrees up, so the audio is really going about straight out from the top of that speaker, because again, we don't want audio much higher than, well, really our heads in this church. maybe, you know, in this area here, mid-wall here. That was their old speakers. That was height's not too bad. If we were doing distributed audio, different thing, we'd bring the speakers down to about the Stations of the Cross, that level on those beams. Maybe a little higher, about right there, but in that vicinity. And go through a simulation and see height-wise where those speakers should be. But the distributed audio issue in a church with echo is, okay, if I'm going to put a speaker, I need one there, 2, 3, 4. That's 4 points of inflection on each side, so that's 8 now instead of 4. And we're really looking to reduce the amount of speakers in these types of churches, simply because that's going to be more amplification, even at a lower level. So you use LRCs to angle the sound down as best you can, and approach it that way, especially instead of saying, well, we'll just replace your speaker up high with another. No. In my experience with church systems, we've found better luck by using, and especially in churches in general, but in churches especially with echo, get the speakers down to near the head level and get rid of your bass also. There's been things where we've used at times, we've seen speakers full of bass in churches. We've swapped them out, gone with smaller speakers, because that bass is just going to cause problems. It's going to really roll the audio in these types of churches. You want that intelligible frequency range pronounced the most, so it's distinguishable. And then after that, you get as small of echo as possible. That's what you're really looking for. The only other way to improve the echo in churches is you're going to have to talk about sound deadening material on the walls, because you have to have a soft material or something to absorb the audio. That's what you would have to do in that particular case. You can only do so much with the physics, even digital signal processing and controlling it. We do have a digital signal, a matrix mixer on here, DSP. What we're doing with it, we had our spectrum analyzer out. We were looking at the frequencies like, okay, 315 hertz range is bad. That lowered and that helped our echo some. And yes, that was 315 hertz, and what we found it at. Also, our inputs, you're going to find with mics that, for example, I'll come up, we're using an Audio-Technica unipoint mic for the pulpit. That is a very good general mic. Frequency-wise, all the frequencies. It's not going to be too bassy and it's not going to be too tinty. The lavalier and the head-worn mic they have are very tinty. So we actually lowered on our DSP. We can have an equalizer for all our inputs separately. We lowered the equalization, the mids and highs of those mics in particular, because it was a little too tinty for this space. So that was lowered. Those were not, because that's more of a general, they're going to give you a little more mid and bass to it. You don't want to take all the bass out, but for your speakers, you don't want to take all the bass out for your mics, but for your speakers, yeah, you want minimal bass rolling through the churches like this with echo. So again, on our equalizer, those are the two things we primarily did. I'll walk in and show you what we're using there. Okay, sorry about that. I'm just in here now, and pardon the camera, I'll just show you what we got in here. Here are 2 amps, front amp, rear amp, 1 channel going to each of the speakers. This is our DSP, Symmetrix Jupiter 8, very nice unit. These are our wireless mics. We will change those labeled because now they're lavalier and head-worn. The wireless mics, we have an external antenna. I'll show you that because you put any of these receivers in a metal rack, boy, you're not going to get much pickup whatsoever outside of this. So the RF venue unit above that is a antenna receiver for our wireless mics. That is connected to our antenna, which is right here. That's the antenna for all the wireless mics. That comes in and then is distributed to the 3 wireless mic receivers right there. Regarding the DSP, they do have control down here with this switch. I'm sorry, yeah, it's a controller on the wall. They have a master volume, and then they have their inputs independently. Pulpit, lavalier, head-worn, head handheld, choir, Bluetooth. Alter and cancer, those are hard lines they don't use, but we have them in the system, and master volume. That's what they had before, so we've just given them the same. They had a different system here that had more handheld controls to do that, but they had the same inputs and things before as they have now. We just gave it with a different brand and giving them more features. Regarding what I was talking about, these are our inputs here. I'll give you a quick show you. The lavalier, for example, this is the input equalizer. We've got that turned down for more of our highs, and we had our analyzer out there showing like, okay, that's going to make the sound better. Same thing we did for the head-worn. Those are the lavalier and head-worn. And then for our output, our general output, there's where we are in about the 315 hertz range, lowering that frequency. This system also has a feedback fighter. If we click on that, these 8 always lock in, or always locked on those frequencies that we know, okay, those could be problems. And these 8 are recyclable. Every 12 hours, they're going to recycle and find new frequencies that could be a problem or an area, and they will lock on accordingly. So that's going to work pretty well. We find it works very well, actually, for these types of conditions where something might change, so you need to always be monitoring that for your feedback control. But yeah, that's a quick look at the DSP that we have that we're controlling, and then their wall control for their system. And yeah, before you throw in the comments, boy, why would you give them, and I understand what you're saying, why would you give them control of all their inputs separately? Don't you want to lock that down? Yeah, and whether you lock it down or not, people open up the case and then they change controls. Like in this case, they can't change anything on the mixer, but they would start changing those volume levels of the outputs. Again, they had the same thing before with 2, well here. This is what they had before, these knobs that they would just push and then change the volume level for their master and their inputs. So we're giving them the same because that was a kind of a non-negotiable request. So we train them well enough multiple times, and then they know that that's how the system works. But I understand what you're saying, and you make a valid point. In some systems, they get locked up totally, and once everything is set, there's no change in it because it's set and that's where it should be. So I get it. Totally get that. But again, there's our front left speaker. 4 total speakers. That was the old speaker, a Bose hanging in the ceiling front of the church. Here's walking across. So again, if you put a speaker on that beam for your front, you don't have audio here in these pews, so you have to start with that beam. Just, that's more along the lines too of whether you're doing the LRCs or even distributed audio. 1, 2, 3. Yeah, you'd need 4 rows with that front right there. But that's going to pretty much sum this installation up and go over the thought process and how we came upon this. but we did work with audio engineers, all the specs on this space, and came up with these model of speakers and how to process them, and ran an audio simulation of what it would sound like, and it sounds definitely a lot improved from what they had with that one speaker, and the amount of reverberation and echo. It's not all gone, but it's definitely less, considerably. So the only way to improve it more, you're going to need sound absorption on your walls. So that's going to do it for this video. I will see you on the next one. Matt, Fisher Custom AV and Treg. Have a good one, everybody.